Okay, the directions for 35 say use the distance formula on the side-side-side congruence postulate to show the triangle ABC is congruent to triangle DEF. Looking here, because the segment from point A to point B is horizontal, all we have to do is look at the x-coordinates. Here we are at an x value of 1 for A and an x value of 4 for B, so that's 1, 2, 3 units. So we don't need to use the distance formula here to know that AB is equal to 3. That should match up with DE. And looking at DE, that segment is also horizontal. So again, looking at the x-coordinates here at 2, 3, 4, 5, 2 to 5 again, distance of 3. So check, check, that works out correctly. Now, B to C, we are going to have to use the distance formula. And the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, and we are calculating the distance from B to C. So we'll do 2 minus 4 squared plus, we went 2 minus 4, now we're going to do 4 minus 1 squared. And the length of BC is equal to the square root of negative 2 squared plus 3 squared. So BC equals the square root 4 plus 9 is 13. Now that should match up, BC should match up with EF. That's what we'll do next using the same formula, EF. So EF will do 4 minus 2 squared plus 3 minus 6 squared. Therefore, EF is equal to the square root of 2 squared plus a negative 3 squared. Remember, the positives and negatives really don't matter here because when you square it, it's going to be positive. So we have 4 plus 9 again, which is the square root of 13. So check, check. We have 2 of the 3 sides congruent. The last sides, we have our sides AC, and AC matches up with DF. So again, using the distance formula, AC, let's see, 2 minus 1 squared plus 4 minus 1 squared equals the square root of 1 squared plus 3 squared. So AC equals the square root of 10. And for DF, we have 4 minus 5 squared plus 3 minus 6 squared. So the length of DF is equal to the square root of negative 1 squared plus a negative 3 squared. Again, the negatives don't matter because when you square them, they become positive. 1 plus 9 is 10. So what we've proven is here, AB equals DE, that's one side. Here, BC equals EF, that's another side. And AC equals DF. So by the side-side-side congruency postulate, triangle ABC is congruent to triangle DEF. And that is how you answer question 35.